Okay, so we are going to simplify the expressions using exponential notation. So that's just telling us they don't want us to actually get the answer on number one. They just want us to combine things. So I've got 3 squared times another 3. So that would be 3 to the third, because now there's 3 of them. If it said evaluate, then you go ahead and do that, and it comes out 27. But they just want exponential notation. So what would be the power on number 2? 9, because we're just going to add the 5 and the 4 together. Okay, number 3. We're going to subtract 8 minus 2. And so we get y to the 6th. And it would technically be 1 on the bottom, but then that just becomes y to the 6th. So if you get 1 on the bottom, you can get rid of it. Okay, number 4, I'm going to take 5 minus 3 and get 4 squared, technically over 1, but they're just going to leave it as 4 squared in the final answer. So those are pretty straightforward. So when you're multiplying, you add the powers. When you're dividing, you subtract the powers. And wherever the power is bigger, that's where that is going to be on your answer. So on number 5, when I just have an x, what's the power on that x? 1, because there's 1 x there. So what we're going to do is we're going to take 7 minus 1, which is 6. But because most of the x's are on the bottom, I'm going to have x to the 6th on the bottom. And then to have a placeholder in the top, I'm going to put 1. And just to explain one more time, 2, 3, 4, 5, 6, 7, why this works. When I cancel x over x, I'm left with 1. And then there's still x being multiplied 6 times in the bottom. So that's why subtraction works, because you're canceling these out. Okay, on number 6, x squared and x cubed make x to the 5th, 2 plus 3. And then I'm going to have y to the, so I got 4, and this would be 1 more, so it would be 5th. Since we're multiplying, we're going to add those. If you want to, you could write out all those x's and y's and count them. I always tell people if you get stuck on a test, it takes a little bit of time and paper, but you can always do that. Okay, so let's look at these. I got 2 to the 5th over 2 to the 3rd. So I'm going to take 5 minus 3, and that's going to give me 2 squared on the top. And then I'm going to subtract 8 minus 7 on the x's, which gives me x to the 1st. Is it going to be in the top or the bottom? In the bottom, because there's more x's there. So they're going to be an x left over. So you can put an x to the 1st there, or you could just say 2 squared over x. Since they wanted an exponential notation, we'll leave it like that. Otherwise, they'd have you do 4 over x. But they still want us to use exponents, so we're good. Okay, what about number 8? X to the, so 9 plus 6 is 15. 1 more makes 16. Good job. So all of this up to this point, this is stuff that we have done. On 9 and 10, and I really feel like this 9 looks like a Q. It's bugged me. It really legit looks like a Q. I don't know. So on this, they've got us doing a couple of things. So the first thing I'm going to do is I'm going to make this a fraction by putting it over 1. That way I can see numerators and I can see denominators. And we're going to start just by multiplying across. So 5 to the 4th times another 5. So this would have a 1, would make 5 to the 5th. And then I'd have x, 2 plus 4 is 6. Then on the bottom, I have 5 squared x times 1, so that's just going to be 5 squared x. So all we did to start with was we multiplied numerators, multiplied denominators, and then we need to see if we can subtract things to make this simpler. So what do you guys think? 5 to the 3rd, x to the 5th, technically over 1, but 1 in the denominator can be taken off because dividing by 1 doesn't do much. So that would be your final answer. So when you have where you're multiplying and dividing, that's how we can proceed. Just multiply the numerators, multiply denominators, then simplify what you have left. Okay, so on this one, I'm just going to cover up the denominators to start with. What power of x will I get when I put these together? 19, and what about y? 4. So when you have a y, that's y to the first. So 3 plus 1, 9 plus 10. Okay, and then on the bottom, I have y cubed x to the 17th. Because these go xy, I'm just going to swap them, put x17, y to the third like that. But it didn't really change anything. These are not the same base, so I can't combine them. They're just going to stay. Then we'll go ahead and do our subtracting. So 19 minus 17, 2. And y to the fourth, y to the third is going to give me y to the first. And technically, everything in the denominator cancels. So this 17 cancels out 17 of those, leaves 2. This y to the third cancels 3 of those, leaves it 1. And so technically in the denominator you have 1, but you can take that 1 off, and if you don't want to put that 1 exponent on the y, you can leave that off too.